Hello viewers, Gayaza taking you through the story for A-Level Applied Mathematics. And this video, we're going to go through the marking guide for Senior 5, Math Paper 2 for end of Term 1 for the year 2024. So this video is suitable for students in both Senior 5 and Senior 6 offering Principal Mathematics as part of their combination. So basically, these are the past papers we hope to upload if time allows. This was already uploaded and now we are going to go through this, after which we shall go to this. So the skipping is intentional, so don't think that it's a mistake, but all of them will be catered for. So like I told you yesterday, there are math books you have to get, and physics and also math, depending on the combination you are offering. So Senior 5 requires you to be well equipped with the books we recommend so that you can easily follow along with them, and also with the videos we upload, because the videos we upload basically explain what is in the books. We are trying to translate them, the notes, to videos. So you really need these particular books. So Math Paper 1, Math Paper 2, Topical Question Bank, and Termly past papers with their marking guides. So for those doing principal mathematics. Then for those doing subsidiary mathematics, it is only one book which contains notes, Termly past papers with their marking guides, and also UNEP past papers with their marking guides. So it's only one book for those doing subsidiary math. Then for physics, there are also 4 books: Physics Paper 1, Physics Paper 2, and Topical Question Bank with its solutions. So if you need any of the books, you contact the author on this line. Some of you are funny. You first look for them in black market, then they give them to you at a high price, then you remember to call. So it's better you call early so that we can make arrangements on how you can get them in any part of the country. So this particular school was able to set 2 papers, Paper 1 and Paper 2. Unlike the previous one I gave you in the previous video, both Paper 1 and Paper 2 were combined into one paper. But for this one, there are 2 different papers, and we shall have a look at both of them. So in this video, I'm going to go through their Paper 2, and maybe tomorrow we shall go through their Paper 1. So Paper 2 has both section A and section B, and section A has 4 questions. That's why you see here 20 marks. So question 1 says, calculate the mean and variance for the data below. So this was under ungrouped data with frequency distribution. So some of you confuse it with group data each time you see frequency, but also ungrouped data can have a column of frequency. So each time there is frequency, question is easily done by tabulation. So you shall tabulate values of x as they are given in the question, then values of frequency as given in the question. Then we have to get their total, add all of these to get the total, which is 25. They ask for mean, so we need a column of fx. So we shall multiply this with this, 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 and after that we add all of them. They also ask for variance, meaning we need a column of fx squared. Fx squared can be got from this times this, 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 and this times this, after which we add all of them. So ungrouped data, the formulas are there in the logbook, but you need to be keen with the calculator, because any single value which you compute wrongly makes everything not okay. For example, there's a student who instead of copying 304, copied 305. That is already off track right from the word go, meaning you have to get 00 out of 5, yet you are supposed to get 5 out of 5. So you need to be keen now that you are in A level. We are sensitive on some things, the presentation, the number of decimal places, and how you use the equal signs. And like I told you, there's a book called Termly Past Papers with Marking Guides, so you can get it and see how solutions are presented, see also the marking points, and you'll be good to go. So Roman 1, they wanted mean. Mean is summation of fx over summation of f. So substitute summation of fx, summation of f to get the output. Then variance, still quote the formula, substitute summation of fx squared over summation of f, summation of fx over summation of f. This is what usually over the sub students, they think that to get summation fx squared, you square summation fx, which is not okay. Summation fx squared means each value of x is squared independently and multiplied by the corresponding f. So one mark was for the sums of these two. Substitution, output, substitution, output. So this involved rounding also, they should be for decimal places. Question 2 says a camels from Kampala to Jinja and back. Its average speed on the return journey is 4 kilometers per hour, greater than that on the outward journey, and it takes 12 minutes less. Given that Kampala to Jinja are 80 kilometers apart, find the average speed on the outward journey. So yeah, the first thing to do is to look at the units. This is per hour, this is minutes. So you have to change one in terms of the other, and it's better you change this to hours because here you already have kilometers or so. So you should be, this question was under mechanics, linear motion, and you don't rush to answer it. So let V be the average speed of the outward journey. Outward journey means moving from Kampala to Jinja. That is the outward journey. Then return journey means moving from Jinja to Kampala. So for the outward journey, we have average velocity. So this denotes average velocity, as we saw here, is equal to total distance over total time taken. So let this be the total time taken for the outward journey. When I make that time taken, I'm making the subject because the question wants you to find average velocity. So I can't eliminate it. That's why I have to make t the subject so that I can easily eliminate it by substitution. So that gives us equation 1. What about for the return journey, that is from Jinja to Kampala? For the return journey, they gave us something. One, the distance remains the same, or distance apart, but the velocity, they said 4 kilometers per hour greater than that on the outward journey. So if the outward journey was 4, the return journey will be 4. Sorry, if the outward journey was V, the return journey will be V plus 4. Okay, what about time? They talked about time, they said 12 minutes less. Meaning that if the outward journey was T hours, the return journey should be less by 12 minutes. So that's why we say T minus 12 over 60. Why over 60? It is because we have to express in same units. This was per hour, so you can't use minutes. You have to use also hours as time. So simplify 12 over 60 is 0.2, so it gives you that. Actually, this interpretation was the most vital. This interpretation was the most vital. Any mistake in that interpretation, everything goes away. So now that we know that, we shall go and get our average velocity, but let's so for this equation 1 had 1 mark. Then the other 4 marks came from this slide. Let's see. So this is the average velocity for the return journey is equal to total distance over total time. Then you substitute average velocity for the return journey, total distance, total time. That gives you equation 2. Then you can substitute for t, because the question wants the value of v. So I substitute for t, where there is t, put the 8 over v, which was in equation 1. Now I have only one unknown, which is v. My work is to simplify and make v the subject, or solve for v. Now when I open brackets, this is what I come up with. Multiply, okay, here what I did, I first cancel these two because they're the same, that's why here there is 0. Then multiply throughout by v to come up with this. Then this is a quadratic, so I have to rearrange to get a quadratic equation which can be solved. Then I can use quadratic formula to solve that quadratic equation. Like I told you yesterday, using factorization in such cases is not that easy, so it is better you also learn quadratic formula. Then use a calculator to get the two values of v. So when you round off, that's what you get. We would have rounding off to 4 decimal places. You get this because even here it was a 0. That's why I chose to just use 3 decimal places. But ideally they should be 4. Okay, so there are two values of v, but should v be negative? No. So we conclude that v is 38.05, which is a positive value. And basically that is what they wanted. Question 3 says, a car consumed fuel amounting to shillings this, shillings this, shillings this, and shillings this, in covering the distances 100, so 100 corresponds to this, 200 corresponds to this, 300 corresponds to this, and 400 corresponds to this. Okay. Estimate using linear interpolation stroke extrapolation the part A cost of fuel consumed for a distance of 450 kilometers. Then distance traveled if fuel is shillings 160,000. So this was under numerical methods in the topic of linear interpolation and extrapolation. Remember, math part 2 is subdivided into 3 parts. There is statistics and probability, there is numerical methods, and there is mechanics. So in this particular school, all were catered for, just as it was in the previous one. Okay. So this 450, you realize that it's outside this range, so we are going to use linear extrapolation. Linear extrapolation, you use two values here closest to the extreme. So we are going to use 300 and 400. Let us extract out these values in a table. So I said you use the extreme ones. If, for example, here I used 200 with its corresponding amount, then it would not be okay, because you must use the most extreme when it comes to linear extrapolation. Then I can equate the two quotients provided I'm consistent. So in this case, I used this minus this over this minus this, which is here. Then this side I used this minus this over this minus this to give you this. Then from there, I'll have to simplify and make x the subject. And that's what they wanted. So some students are funny, they don't want to extract out this table. That is called too much Weizsäcking. So I think you realize that you will miss this mark, and all the rest you will miss because we don't know where they're coming from. So always remember to extract out a table in the questions of linear interpolation and extrapolation. Part B, still we are going to extract out the table. and this time we shall use linear interpolation, because 160,000 is between this and that. Then we shall equate quotients. Now here there are different methods. Others choose gradient method. It is still okay, provided you are consistent. Provided you are consistent and keen on what you are doing. So simplify and make y the subject, and that will be the distance they wanted. So that is how you could get the 5 marks in this question. Question 4 says, a body of mass 3 kilograms resting on a rough horizontal surface with a coefficient of friction 0.525 is connected by a light inelastic string passing over a smooth fixed pulley at the edge of the table. The other end of the string carries a mass of 5 kilograms and the system is released from rest. Okay. Find the tension in the string and the acceleration of the bodies. So here, this is under mechanics, connected particles and Newton's laws of motion. So it combines connected particles, Newton's laws of motion, and friction. So we shall need to make a sketch. And remember, mechanics, force diagrams are drawn with a ruler. In mechanics, force diagrams are drawn with a ruler. For example, this string is tight. Okay. Now, if a student uses free hand and draws something like this, do you see something? Can a tight string have this hip? No. So it will be wrong right from the word go. So that's what I've been telling you about A level. We are sensitive over some things which you don't need to undermine. So here, if I see you not using a ruler, I just know it is a 0 out of 5. I don't need to look at the calculations we have done. However good they are, however correct they are, the diagram does not rhyme with the calculation, so I can't give a mark. So always remember, each time you realize that there is a question in mechanics, in an exam you're going to do, remember to carry a ruler. And the good thing in senior 5 means that the ruler must be reasonably new. Reasonably new, because some rulers, when they get old, they have some rough things. So you may draw something and there's something not okay, which shows that it's not a straight line. So I've taken long talking about a ruler. Remember to get a ruler. So next we shall put now the forces. We shall begin with the weight. Weight always acts vertically downwards. Then because of this weight, tension must go up. This was going down, this should go up. Because this is going down, up, this should go down. Now T is the same because the string is still the same. If a string changes, tension also changes. As we shall see, there's another question where a string changes. But for this particular one, from here up here, it is just one string. So tension in the string must be the same. And 2, the way you draw arrows sometimes disturbs. Some of you do this. You put this and also put this, and you just put your 1T. It is not okay to combine these 2 arrows and call them T. These 2 arrows must be separated, just as you see here. And each arrow must have its own T. There are reasons why as you progress in these force diagrams. So make sure you separate the arrows. Each arrow must have its own tension. Okay, when that is done, now they told us something about friction. So for you to know friction, you should remember that friction opposes motion. Therefore, the first thing to do is to ask yourself, in which direction is this body moving? Is the system moving when released? Okay, but before that, let's also do the weight for this. And because of the weight, now because this weight is lying on a different surface, there should be no more reaction. I think you realize that for this one, there was no normal reaction. Why? Because normal reaction is when a weight is lying on another weight, or a weight is lying on a surface. There should be a reaction. But here it is just suspended by a string, so there can't be normal reaction. So here there is reaction, okay. Then you shall ask yourself, when released, in which direction does it go? That direction must be specified on your diagram with the arrows of acceleration. So this arrow of acceleration is what shows the direction of motion. It is after that that you can put friction in a direction so as to oppose motion. So this particle moves this direction, therefore friction must move in the opposite direction. Mu r. So now that we have finished drawing the diagram, we can now do the calculation bit of it. So for the 3 kilogram mass, this one, it moves. These are the forces of interest. Okay, let me do this. Forces of interest are these ones, where we shall apply Newton's laws of motion. Why are we dealing with that? It is because of the direction of motion is horizontal, so we shall deal with the horizontal components. So moving this direction, meaning this force is bigger than this. Therefore, the resultant will be T minus mu r equal to ma, where m is 3. Okay. We know the value of r. This r is equal to this 3g, where g is 9.8. So that is 9.8 is a constant. Remember, in your O-level physics, g was taken to be equal to 10. Okay, but now in A-level, the value of g somehow changes. In mathematics, in A-level math, the value of g is 9.8. And when we go to A-level physics, as we shall see later in the video for physics, the value of g is taken to be 9.81. So don't confuse the values of g depending on the subject you are attempting. So that gives us equation 1. Then equation 2, this acceleration is down vertical, so we are interested in the vertical components. Moving down, meaning this g, 4g is greater than this, so the resultant will be 4g minus t equal to 5a. Sorry, 5g minus t equal to 5a. Substitute for g and get equation 2. So the good thing, we have 2 equations and 2 unknowns, meaning you can use the knowledge of Math Paper 1 for solving simultaneous equations. So before we go do that, let's see the marks for this slide. Okay, so next is to solve simultaneously. When we add the 2 equations, this is what you're going to have. So this will cancel with this, then this minus this gives you this plus this gives you that. Then you'll be able to get the value of acceleration. Roman 2. Oh, okay, one was that acceleration and the other was tension. So let's say how to get tension. So from equation 1, which is this, we can substitute for a and get the value of t. And that's what they wanted. So that's how we could get the 5 marks out in this question. But be keen, force diagrams are drawn using a ruler, and a reasonably new ruler. That was section A. Now we shall go to section B, where each question carries 12 marks. So question 5 says each of 50 sportsmen was asked to state the distance y kilometers he needs to travel to obtain access to suitable training facilities. Okay, the results are summarized in the table below. Then part A, construct the cumulative frequency table for the distribution and draw the cumulative frequency curve. Okay. Then part B, use your curve to estimate Roman 1, the interquartile range of the distances. The percentage of sportsmen who need to travel more than 40 kilometers. So this question is under grouped data, and questions for group data are easily done by tabulation. So because they need and or give, we need to get a column of cumulative frequency. So cumulative frequency table, we shall come and first draw the table again. The distance, we shall do that. Now, there is something I've done. You see here, there are inequalities. But in my table here, I've removed the inequalities. Why? Because for inequalities, each time you see an inequality, it implies that the class is the same as class boundary. Therefore, you can put both class and class boundary in one column. So this column represents a class and also represents a class boundary. Okay, so in O level you could be allowed to put the word class here, but now you have to put what is in the question. Okay, the number of sportsmen, that is frequency. F, we shall just write what is given. Then for cumulative frequency, we shall keep on adding cumulatively. So first write 1 here, then plus 2, it gives that plus 6, plus 20, plus 15, plus 6, and that will be the table they wanted. So in that question, they also wanted you to draw a cumulative frequency curve. So cumulative frequency curve, you'll need a graph paper. So you come here and get a graph paper, and then we draw the axes. Now, axes are drawn even before getting a scale. Some students are funny. You know how funny they are? They can come, the whole of this is a graph paper. Then they draw the axes here, like this, here, and here. That is not okay. Why are you leaving all this space? And why are you leaving all this space? So that is why we advise that you draw the axes even before getting the scale. How? Make sure you leave only the space where you can write the scale. Only writing the scale and labeling the axis. Only that space. So some graph paper, here I've left 1 centimeter because some of the graph papers, they will have this white thing. So that white thing can also be used to to label the axis. But if it doesn't have, or if it is small, then you can leave 2 centimeters. So those are the only permitted spaces on graph work. Either 1 centimeter or 2 centimeters. Either 1 centimeter or 2 centimeters. If you go beyond that, it is not acceptable. Okay. After doing that, then we can demarcate. Leave intervals of 2 centimeters. Intervals of 2 centimeters. Then the scale must be uniform. So in O level, the group data you had equal class widths. But now in A level, the classes you have can have an equal class width, just as you see here. From 4 you go to 10, from 10 you go to 20. Now if you just plot these ones as they are, then your graph will have non-uniform scale. So make sure you get a scale which is uniform. For example, here I use the spacing that each 2 centimeters represents 10 units. That is okay. Then you also do the same for the vertical axis and get a scale for it. So vertically use that 2 centimeters represents 5 units. Now in O level here, they will tell you to put cumulative frequency, and here they will tell you to put upper class boundary. Okay, now something has changed. You must put what is in the question. If a question has cumulative frequency, then you put it there. But in this case, the question did not have that. So you must put what is in the question. Let us go to the question and we see what was there. Here it was about distance and number of sportsmen. That is why we are using those two. Distance and number of sportsmen. But again, it shouldn't confuse you. You shouldn't think that you are going to plot these ones. In plotting, you are going to plot cumulative frequency. So when you're plotting, we need these two values, this and this. Those are the ones we shall plot. For example, 4 will correspond with 1 to give you this. 10 will correspond with 3 to give you this. 20 will correspond with 9 to give you this. 35 will correspond with 29 to give you this. 60 will correspond with 44 to give you this. And lastly, 90 will correspond with 50 to give you this. Then you have to draw a reasonably smooth curve. Reasonably smooth curve. Now this curve, some students are funny. They get the paper, they get the graph paper and they put it directly on a table. That shows that the graph will never be smooth and you'll never get a mark for a smooth curve. So what do you do? The graph is put on top of the answer sheets. Because they give you a graph paper and also answer sheets. Put the graph paper on top of the answer sheets, then draw. There it will be somehow smooth. Okay, it will be reasonably smooth. So we need to draw through, and it must pass through all the points. It must pass through all the points, and it should not be left hanging. For example, if I leave it here, it is not okay. Why is it hanging? So take it up to the origin. Take it up to the origin. 2. How do you know which point to start with? For the horizontal axis, start with the lower class boundary. For the vertical axis, start from 0. Hope that makes sense. For the horizontal, it is not a must that it should be 0. It is 0 because in this case, our lower class boundary is 0. But for the vertical, you have to start from 0. Okay, so now let us draw a reasonably smooth curve through all the points. So that is the cumulative curve, frequency curve they wanted. Now let's look at part B. Part B, they want you to use your curve to estimate the interquartile range and also the percentage of sportsmen who need to travel more than 40 kilometers. So let's first get this interquartile range. First, you need to get the position. So I'll come here and say, choose one position. Choose one is used to denote lower quartile. So lower quartile position is 12.5. Therefore, I'll come back to my graph and look for 12.5 and take a horizontal line to meet the curve, drop a perpendicular to meet the horizontal axis, and read off that value. It will be 23. Therefore, our lower quartile will be 23. So I can come here and say Q1 is 23. Then for the upper quartile, position is 37.5. So come here and look for 37.5. Take a horizontal line to meet the curve, draw perpendicular to meet the horizontal axis, and read off that value, 46.5. Therefore, we shall come here and say that 2, 3 is 46.5. Therefore, the interquartile range is got by subtraction. So some students were confusing the interquartile range with the semi-interquartile range. They were instead dividing by 2. That becomes semi-interquartile range. But the question only wanted interquartile range. So your work was to subtract the two values. Okay. Then we shall go to Roman 2. So after subtracting, that is when it is okay to round off. But in this case, let us go to the graph and see. In this case, these values were for distance. So it is okay for distance to be in decimals. Therefore, there's no need to round off. If it was good from here, we would have rounded off because number of sportsmen, these are people. They can't be in fractions. Just as we are going to see. So next was percentage of sportsmen who need to travel more than 40 kilometers. Actually, this is percentage, so percentage can also be in decimal. So more than 40 kilometers shall come on the axis for distance and look for 40 kilometers. Take a vertical line up, take a horizontal line to meet the vertical axis, and read off this value. Now that value is for the number of sportsmen who can travel below, who travel a distance of less than 40 kilometers. The one above is the remaining part, which is 50 minus 32.25. So you come and say that number of sportsmen traveling less than 40 kilometers is 32.25. So here it is okay. It is okay to round off. It is allowed. But because they were asking percentage, it means that it is also okay if you leave your answer here, because the question was not number of sportsmen. It was just percentage of sportsmen. So both these two students will be correct. The number of sportsmen traveling more than 40, you get it by subtracting. So when you subtract, you can come up with this. So like I said, you either get this or you get a whole number. Both of the two are marked. So otherwise, if they had just asked for number of sportsmen, then this would be wrong and this would be correct. It means that after writing this, you have to round off to this. But because they asked for percentage, it means that it is allowed for it to remain a decimal. Then you can now go to the required percentage, which is that. So still, if you use this one here, it will still be correct. So that is how marks will be awarded for this slide. So those are the 8 marks. What about for the ogive? Let's also see the ogive. Here there was a mark for cumulative frequency column, a mark for labeling the axes and uniform scale, a mark for plotting all correctly, and a mark for reasonably smooth curve. So that's how you could get the 12 marks in that question. Then question 6 says, part A, at t equal to 0, a body is projected from an origin O with an initial velocity of 10 meters per second. Okay. The body moves along a straight line with a constant deceleration of 2 meters per second squared. Roman 1. Find the displacement of the body from O after t equal to 7 seconds. Roman 2. How far from O does the body come to rest, and what time does it take to come to rest? So we shall come here and say that for Roman 1, we shall use the first equation of motion and substitute for u, initial velocity, t, time taken, deceleration negative because it's a deceleration, and time to get the displacement they wanted. Then for Roman 2, they said how far from O does the body come to rest and what time does it take to come to rest. So when it comes to rest, it means that final velocity is 0. So you'll come here and use third equation of motion, substitute for final velocity, initial, acceleration, and you have only s as the only unknown. So when I simplify, s will be 25. But they also ask for time, so I can use first equation of motion, substitute, and get the time. That was part A. Then part B says a car started from rest, accelerated uniformly to attain a velocity 20 meters per second in 40 seconds. Okay. It maintained the velocity attained for 50 seconds. And then brought to rest by a constant braking force in 20 seconds. Sketch a velocity time graph for the motion. So first it was accelerating to attain this velocity from 0 to 20 in 40 seconds. So let's first draw that. So this is just a sketch, you don't need the graph paper. So you draw the axis. They said 40 seconds to attain a velocity of 20 meters per second. So you can join from start to end, from here up to here, but using a ruler. Okay. Then they said it maintained the velocity attained for 50 seconds. So for a further 50 seconds, the time here will now be 40 plus 50, which is 90. And the velocity was the same, so it would just be a horizontal line. Okay. Then from there they said, and is then brought to rest by a constant braking force in 20 seconds. Brought to rest, meaning that the final velocity is 0. And that happened in 20 seconds. So 20 plus 90 is 110. And that's what they wanted. Then part B, this Roman 2 said, determine the total distance traveled by the car using the graph sketched. So total distance is equal to area under the graph. So that shape is for a trapezium, meaning that area we shall use formula for area of a trapezium, which is that. So a half times height, which is 20, then A, which is this 50, and B, which is this 1, to give you 1,600 meters. So basically that's what they wanted. So substitution, output, substitution, output, substitution, output. This graph for the axis labeled, one for this first stage, second stage, third stage. Substitution, output. So basically that's how the 12 marks would come about. Then question 7, part A says, by plotting graphs of this and this on the same axis, obtain to 2 decimal places the roots of the equation this in the interval this. So this is under numerical methods, the topic of root, location, and approximation. So let's first start with part A. This one needs a graph paper. So we need to tabulate the values to use. So we shall come and put for 0.2, negative 2 when x is negative 2, sine 2 sine negative 2 gives you negative 1.8. So now that there is a trigonometry, you are supposed to change your calculator to radians. If you don't, then the values will be a little weird. When x is negative 1.5, y will be that. When it's negative 1, we shall get that. When it is negative 0.5, when it is 0, when it is 0.5, when it is 1, when it is 1.5, and lastly when it is 2, you get that. So those are the values we shall plot. So after getting those values, we can come here and get our graph paper, draw the axes. Now these values had positive and negative, so we shall draw our axes to make sure that we cater for both negative and positive values. Then we get a suitable scale for the horizontal. For the positive values, we shall use that. For the negative values, we shall use that. Then vertically, positive we shall first demarcate. Then positive values, we shall use that, and negative values, we shall use that. Then we can start plotting. So this corresponds with this. So we'll come and plot it. This corresponds with this. 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 And this corresponds with this. So we need to draw a reasonably smooth curve through all the points. Reasonably smooth curve through all the points. So let's do that. So that from there to there, then also we proceed and complete. Then we have to label the curve. Then they also wanted the line y equal to x, so we can just means that y value is the same as x value. So negative 2 with 2, negative 2 gives that, and 2 with 2 gives that. So you can draw using a ruler, Okay, and label the graph. That was part A. What did they want us to do with the graph? They said by plotting, obtain to 2 decimal places the roots of the equation. So the roots of the equation are the points of intersection. So at this point, there's an intersection, so we shall draw a vertical line up and read that value. So it is actually negative 1.9, but because they say 2 decimal places, we have to put 1.90. Then also here, positive 1.90. And that's what they wanted. So let's see the marks for this part. So axis being seen and scale is uniform, 1 mark. Plotting these points here, all these points seen, that is 1 mark. And also joining using a reasonably smooth curve, that is 1 mark. This one is for the line well labeled. This one is for the negative root seen and positive root seen. That was part A. What about part B? Part B says, use a suitable table of values to show that the equation this has 1 negative root and 2 positive roots, and hence determine the intervals in between which the roots of this equation lie. So this is about tabulation. So that is our fx. So you have to get values of x with their corresponding value of fx. Negative 3 corresponds with this. Negative 2 corresponds with that. Negative 1 corresponds with that. 0 corresponds with that, 1 corresponds with that, 2 corresponds with that, and 3 corresponds with that. So we shall need a change of sign. There's a change of sign here, a change of sign here, and a change of sign here. So you have to give a reason. Since there's a change of sign here, it means that the root is between this, which is negative. Also, there's a change of sign here, so the root is between that and it's a positive. There's also a change of sign here, so the root is between that and it is positive. So there is one negative root and 2 positive roots. And that's how marks will be awarded. That was question 7. Now we shall go to question 8. Question 8 says, a body of mass 20 kilograms rests on a smooth horizontal table. It is connected to other 3 kilogram and 12 kilogram bodies to its left and right, respectively, using inextensible strings passing over smooth fixed pulleys at the 2 edges of the table. Okay. If the system is released from rest, okay, find part A, the acceleration of the bodies, part B, the tensions in the strings, and part C, how far a 2 kilogram body will move in 10 seconds. So this is under mechanics, still on connected particles. So we shall need to make a sketch using a ruler. First diagrams are drawn using a ruler. Then we shall put the weights. 3 kilogram mass is here, tension is here, T1, T1, and also here, T1, T1. Here there is weight and normal reaction because this one is lying on a surface. Then there is T2 now. So T2, because these 2 strings are different. T2, T2, and the weight. They said it is smooth, so there is no friction. Therefore, when released, this heavier one will move downward. And this one will move upward, implying that this will move to the right. Okay, so now for the 20 kilogram mass, 20 is here, acceleration is this side, so we are interested in this. This is bigger than this, so we shall say T2 minus T1 equal to 20A. For the 3 kilogram mass, upward, meaning we are interested in this, T1 is bigger than 3G, so T1 minus 3G is equal to 3A. Substitute for G, you get equation 2. So before I go to the next slide, let's see mass for this slide. Then for the 12 kilogram mass, it is downward, so we're interested in this. 12 is bigger than T2, so it will be 12G minus T2 is equal to 12A. Substitute for G to get equation 3. So we have 3 equations, 3 unknowns. The unknowns are T1, T2, and A. And we need to get all of them. So adding equation 1 and equation 2 and 3, we shall be able to eliminate. Have we eliminated anything? No, we have not eliminated, but we have got T1 minus T2, which can be used with equation 1. I think you see equation 1 has T2 minus T1. So we can use both of them to eliminate all the tensions. So when we do that, we are going to come up with this. So you realize that this T2 goes with this and this T1 goes with this. So here I remain with this and here I add these two to get 35. Then make A the subject. So let's see mass for this slide. Okay. Then part B, here they wanted actual acceleration alone. Then part B, what do they want? Let me see. Part B, they wanted the tensions. Okay. So tensions, we shall come here and say, after getting A, you can say from equation 2, substitute for A and get the value of T1. Then also from 3, you can substitute for A and get the value of T2. And that's what they wanted. Then part C, this should be C. So part C, let's see what they asked for. Part C, they said how far a 12 kilogram mass body will move in 10 seconds. So you have the time, you have the acceleration. They said it was released from rest, so you have the initial velocity. Okay, so we shall come here and say second equation of motion, substitute for initial velocity, it was released from rest. Acceleration, we know it, and time, we know it, so distance will be that. And that's what they wanted. So basically, that's how you could get the 12 marks from this question. And that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on Physics Paper 1, end of Term 1 for Senior 5. So if you have not yet subscribed, please click on the subscribe button below this video so that I can receive updates when the next video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so you can all benefit